This section is on an introduction to functions, relations between numbers, functions, and evaluating functions. So first of all, a relation, different ways to represent a relation. We have a mapping. We map from the domain to the range. So in this case, -1 is put into this magic math box and mapped to 8 in the range. 2 is mapped to 8, 5 is mapped to 7, 5 is mapped to 10, and 7 is mapped to 10. That's one way to represent it, is this mapping. We can take the same information, put it as ordered pairs. So the -1 mapped to 8 is -1, 8. 5 to 10 could be 5, 10, and so on. We can write it as a table of values. We can also graph these points on a Cartesian grid. Now, functions have predictability, though, meaning that whenever you put something in from the domain, you always know exactly what's going to come out. So it's a type of relation in which each element of the domain is paired with exactly one element from the range. And so if we have a domain 2, 3, 5, 8, a range 0, 6, 7, 9, here's our mapping. So we know that when 2 goes in, 6 will come out. 3 goes in, 0 will come out. 5 goes in, 7 comes out. 8 goes in, 9 comes out. There's no other possibilities for what can come out. This is also a function because no matter what you put in, there is this predictability. If you put in 1, you get 8. If you put in 3, you get 8. 4, you get 8. 8, you get 8. The fact that they all end up at the same thing does not mean that there's no predictability. They just happen to all end up at the same place. So this is still represents a function. In this case, the domain for a Cartesian grid is the x values, the range is the y values, so our domain would be -6, -4, and 2. Our range would be -4, the height of that lowest point, 2, 4, and then 6 is the highest point there. Now, as far as a mapping, here's our mapping. Now, this would not represent a function because you do not have that predictability. That is, if you plug in 2 in particular, you don't know if you're going to get out 2 or 6. So this relation is not a function. One element of the domain is paired with more than one element in the range, not a function. Okay, here we have ordered pairs. We can represent it as a mapping. So here's our domain, the x values. Here's our range, the y values. We draw in the arrows. Here's our table of values. Here's our graph, our 5 points from the ordered pairs. What we see, of course, is this is not a function because 7 gets mapped to 2 different values in the range. There's the domain, there's the range. We put them in numerical order, and notice it's not a function. Also, does not then pass the vertical line test. This is where the vertical line test comes from. So we see this is not a function, does not pass the vertical line test. Okay, the graph on the left. Of course, it is a function, passes the vertical line test. We only hit one point at a time. Therefore, each member of the domain only gets mapped to one member in the range. Put over here on the right, of course, not a function. We have, doesn't pass the vertical line test. Plenty of places in the domain that get mapped to 2 places in the range. All right, now evaluating functions. Changing gears a little bit. We have g of x equals 2x plus 1. h of x is 4x squared minus 1. What this, of course, means is you take some number, you put it into this function g, and the function g multiplies it by 2 and adds 1. If you take the number and plug it into the function h, it squares it, multiplies by 4, and subtracts 1. So to evaluate these functions, you simply plug in the number for x. So 2 times 3 plus 1 instead of 2 times x plus 1. For 7, here's g of -5, g of k, g of r plus 1, and then simplified. Here are some h evaluations. Plugging in 2, plugging in 0, and then plugging in z. So we see the evaluation there for a moment. Now we have this function in 4 individual spots in the domain. So we're going to evaluate the following equation for that given domain of just those 4 x values and see if it represents a function. And so we evaluate each one of those, plug in -1, plug in 0, plug in 1, and plug in 2 for x. Find out what y is for each one. That gives us our 4 ordered pairs. We plot each one. We can see, of course, this does represent a function, passes the vertical line test. If you were to extend this domain to all real numbers, we could get ourselves a parabola as well.